What is up, everybody? This is going to be a very interesting video, and it's about derivatives and how they apply to calculus. So let's go. So we're given the function x to the 3 plus 4x to the 2 plus 5x plus 1. Now they're asking us here for two things. What's the equation of the tangent line? And what is or um, are there any horizontal tangent lines? So here's what we need to know. So what is a horizontal tangent line? So let's say we were to have a graph. This is our graph. And let's say that we know that a derivative is kind of like the slope, right? Well, if a slope is horizontal, the slope is 0. So let's see how that applies later, okay? All right. First off, let's stick with the equation of the tangent line. So to get the equation of the tangent line, first, we need to know what points. So let's use the point -2 and -1. So let's find it as point -2 and -1. So if your teacher gives you this, you should first of all plug in your x value, which is this, into your equation over here to make sure that you get out -1, or else the point doesn't make sense. So let's go. All right, what's the equation of the tangent line? Okay, so first off, let's get the derivative. What's the derivative? Let's go. So f prime of x is equal to 3x squared plus 8x plus 5. And the derivative of a constant, 1, is 0. So we don't have to add it. Now, sorry, let me just make my f a little bit better. Now we can plug in our -2. So 3 of -2 squared plus 8 of -2 plus 5. Well, this should equal, let me use my calculator, 3 -2 squared plus 8 -2 plus 5. Well, this gives us 1. So what is this? Well, this is our slope. 1 is our slope. So let's save that. Okay? So we'll just write it over here. M equals 1. Now, we should know point slope form, I believe is the name of it. Y minus y naught equals your slope times x minus x naught. Okay. All right. So what's our y? Well, we don't know yet. And what's our y naught? Our y naught and x naughts are up here. So let's use those to plug it into the equation. Y minus 1 is equal to our slope, m, 1 times x minus our x naught, which is -2 minus 2. Okay. Now, as we know, minus minus is plus. So y plus 1 equals 1x plus 2. We can distribute our 1, which is just going to be x plus 2. That doesn't change. But then we need to minus 1 because we're bringing this over. So this turns out to be plus 1. Okay? So this is our equation of the line. And we're going to save this for later. So that's the equation of the tangent line at the point -2, -1. Isn't that wonderful? Okay. That was beautiful. Now let's focus on finding the horizontal tangent lines. So to find the horizontal tangents, we need to know when the derivative is 0, correct? So let's rewrite our derivative. 3x squared plus 8x plus 5 equals 0. Now we need to factor this. So as we see, our a is 3. It's not 1. So we need to do long RS factoring. So how do we do that? Let's multiply 3, our a and our c, which is a and 5, and we get 15. And then our b is 8. So what numbers multiply to 15 and add to 8? That's 3 and 5. So now we can rewrite this as 3x squared plus 3x plus 5x plus 5 equals 0. And now we can factor out. So what can we factor out from these two terms? Well, in the first term, we can factor out 3x. So 3x. And then what's left is x plus 1. Now what can we factor out from the second term? We can have a 5. So 3x plus 1 equals 0. So now that they're in terms, we can now do 3x plus 5 and x plus 1. Now it's completely factored. Now we have to know when it equals 0. So as we know, anything multiplied by 0 is 0. So either this or this is 0. So let's see. Oh, sorry. This is 0. 3x plus 5 equals 0. When 3x equals negative 5, which means x equals negative 5 over 3. And this one is 0 when x equals negative 1. So now let's plug these back into our original equation. So this one might be a little bit messy. Negative 5 over 3 cubed plus 4 negative 5 over 3 squared plus 5 negative 5 over 3 plus 1. This is disgusting, but it is what it is. So let's see that on the calculator. Negative 5 over 3 cubed plus 4 negative 5. I'm not sure what the hell is going on here. Negative 5 over 3 squared plus it says at the top plus 5x, so plus 5 negative 5 over 3 and then plus 1. We get negative 23 over 27. Beautiful. And for the second one, it's going to be a lot simpler. So negative 1 cubed plus 4 negative 1 squared plus 5 negative 1 plus 1 on my calculator. Hang on. I should be able to do this in my head, but I'm a little bit tired. So negative 1, 3 to the 3 plus 4, negative 1 squared plus 5, negative 1 plus 1 should equal negative 1. Beautiful. Negative 1. Absolutely gorgeous. So now that we have these, let's just verify all of our answers to make sure that they are mathematically correct. Okay, so let's use Desmos. Beautiful app. This is our equation of the line. So we said that the equation of the tangent line at the point negative 2 and 1 is y equals x plus 1. So this is the point right here. I'm not sure if you guys can see where negative 2 and 1 is, but let's just plug it in. So y equals x plus 1. Wow. Absolutely gorgeous. As you can see, it touches exactly on that point, so we are correct. Now, horizontal tangents. Where are there horizontal tangents? Visually, I can see it. There's one right here at negative 1 as an x value, and one somewhere in between negative 1.5 and negative 2. So we said that, let's go back to our notes. We said that there was at negative 23 over 27 and negative 1. Let's check that out. Y equals negative 23 over 27. Would you look at that? Absolutely beautiful. And y equals negative 1. Would you look at that? Please admire the art that we just did here. It is absolutely beautiful. These lines are parallel. It is wonderful. Anyways, guys, this is the beauty of it. And Okay, I hope you guys learned something, and that's it. Bye.